two variable linear regression model. The other type of parameter is sigma u square. When sigma u square is unknown, estimation of the sigma u square will be the estimated error u hat is equal to y minus y hat, y minus alpha hat minus beta hat x. S is equal to sum of I equal to 1 to n u hat I square. Error term must be minimum, so we can write u hat is equal to alpha plus beta xi plus ui minus alpha hat minus beta hat xi. If we manipulate this equation and rearrange this equation, we get ui minus u bar minus beta hat minus beta into xi minus x bar. So ui minus u bar minus beta hat minus beta into xi. We know that capital Xi minus capital X bar equal to small xi, and S is equal to sum of ui hat square is equal to expected value of ui minus u bar minus beta hat minus beta xi whole of square. And we are break this term as a plus b a minus b whole square, and getting and taking expected value of ui hat square is equal to expected value of sum of ui minus u bar whole square plus expected value of, that means b square, expected value of beta hat minus beta square into sum of xi square minus 2ab 2a means expected value of sum of ui minus u bar into beta hat minus beta xi. An expected value of sum of ui minus u bar whole square is equal to expected value of sum of ui square minus n into u bar square, n into expected value of ui square minus expected value of sum of u bar square is equal to n into expected value of ui square minus n into expected value of u bar square, n into sigma u square minus n into expected value of u bar square. And finally we get n into expected value sum sigma u square minus n number of sigma, so n by 1 by n square sigma expected value of sum sigma ui square. Finally we are getting n into sigma u square minus 1 by n into n sigma u square, and sigma u square taking common, and the value is n minus 1 sigma u square, and the etc beta hat minus beta into sum of xi square. We know that beta hat minus beta square will be sigma u square by sum of xi square into xi square, so xi cut down, and ultimately value will be sigma u square. And the other term is ui minus u bar into beta hat minus beta xi is equal to sum of ui xi minus u bar xi into wi ui. We know that wi ui is equal to beta hat minus beta. So the next line is sum of ui xi. We are multiplying both the terms, sum of wi xi into sum of wi ui minus sum of ui xi into sum of wi ui, here u bar, and u1 x1 u2 x2 up to un xn, w1 u1 w2 u2 wn xn minus u bar and rest of the terms, and we are getting that x1 w1 u x1 w1 u1 square x1 x2 w2 u2 square xn wn un square, and taking expectation and getting expected value of sum of ui minus u bar beta hat minus beta into xi is equal to expected value of wi xi ui square plus w expected value of wn un square xn and expected value of u bar. It's getting the value, and by following the step we get sigma u square, and that is equal to sigma u square into 1, that is equal to sigma u square, and summation wi ui is equal to 1. Finally, expected value of sum of ui square equal to n minus 1 sigma n u square. So sigma u square minus 2 sigma u square 1, so sigma. So finally we get sigma u square common, and in the bracket we will have n minus 1 plus 1 minus 2. So sigma u square n minus 2 sigma square etc value of ui hat square into n minus 2. Here n is the number of observation, 2 it's a number of parameters or number of regressor, plus 1